Welcome everyone to online lecture series of electronics subject. This is part 2 of electronic instruments, that is first chapter from paper 1. In earlier part 1 we have studied half part of CRO, that is in detail block diagram of CRO, CRT and electrostatic focusing system. This chapter consists of two more instruments, function generator and digital multimeter. So in this part, we will be studying the remaining part of CRO, function generator and digital multimeter. So in this part, electrostatic deflection system, difference between electrostatic deflection system and electromagnetic deflection system, time-based generator, front panel controls of CRO, applications of CRO, block diagram and explanation of function generator, block diagram and explanation of digital multimeter and applications of DMM. Let us begin with electrostatic deflection system. There are two types of systems available in CRT. One is known as electrostatic deflection system, that is in front of you, and one more is available, that is electromagnetic deflection system. Let us discuss electrostatic deflection system. As shown in this diagram, there are two deflecting plates which are maintained at different potentials. In figure, the lines of force between them are shown. When an electron beam enters the electric field, it gets deflected towards positive plate and the path becomes positive. Path becomes parabolic, like this one. Okay, so this is shown here. The beam emerges out in straight line and travels towards point P dash on the screen. In a CRT, two pairs of deflection plates are used. Input to be displayed is applied to vertical deflection plates. Generally, a sawtooth voltage is applied to horizontal deflection plates. The final change in the direction of electron beam depends on the combined effect of both. The position of the spot P dash, this P dash, depends on the factors like speed of the electrons, size of plates, distance of screen from the plates, and voltage applied to deflection plates. In CRT, amount of deflection depends only on the voltage applied to the deflection plates because all other factors are fixed. Application of this system. It is used in cathode ray tubes which are used in CRO. Along with this one, deflection sensitivity also observed. Deflection sensitivity of a CRT is defined as deflection on the screen in meter per volt of deflection voltage. Now is the comparison. Magnetic deflection system, this is used in radar. So it is not there for the syllabus. Electrostatic deflection and electromagnetic deflection. So this one is the difference or the comparison, few points in between electrostatic and electromagnetic deflection system. In case of electromagnetic deflection system, the beam is deflected by magnetic field, while in case of electrostatic, it is deflected by electric field. Two sets of current carrying coils are used to deflect the electron beam in case of electromagnetic deflection, while in case of electrostatic, deflecting plates are used. These deflecting coils are placed outside in case of electromagnetic, while In case of electrostatic deflection, these plates are placed inside the tube. In case of electrostatic, the deflection of the spot on the screen is proportional to the potential difference applied to the plates, while the deflection of the spot on the screen is proportional to the current flowing through the coils in case of electromagnetic deflection system. By using electromagnetic deflection system, electron beam deflected over larger distance. Why? Because the coils are placed outside, while in case of electrostatic, the electron beam is deflected over smaller distance. It is used in case of CRO and ECG monitors, and electromagnetic deflection system is used in case of TV picture tube, radar display and video display in case of computers. Time-based generator, or it is also known as sweep generator, which is one of the important block in case of cathode ray oscilloscope. The need of time base is to represent time on x-axis, which will scan the beam from left to right with particular rate. The deflection of spot is proportional to the time and it is along x-axis, hence name as time base. Internally, sawtooth voltage is applied to the horizontal plates. Sawtooth generator uses the principle of charging and discharging of the capacitor. As you can see, resistor and capacitors, these two are connected in series. During the charging process, spot moves from left to right, and during the discharging time, spot returns to the left side and the process continues. You can see clearly with the help of this diagram. That is, from this point to this point, it is called as a charging of the capacitor, and once the capacitor fully charges, it discharges and the beam moves. The charging portion is called as trace, while the discharging is known as retraced or flyback. During flyback period of electron beam is made cutoff by blanking circuit. Now this figure shows simple unijunction transistor, that is UJT sawtooth oscillator, as a time-based generator. When the supply is made on capacitor, this capacitor charges exponentially through resistor R, emitter voltage rises towards the supply voltage VPB, and when that VE reaches to the peak voltage, then emitter based diode becomes forward bias and UJT gets fired. This emitter voltage, this is the emitter terminal of unijunction transistor. This provides a low resistance discharge path between emitter and base B1. So capacitor gets path, this capacitor gets path to discharge through base B1. At this instant, emitter base junction is reverse bias and capacitor starts charging once again through resistor like this. This cycle of charging and discharging repeats continuously. Charging value and discharging value will be decided. The changing values of R and C can vary the frequency of oscillation. So in this way, with the help of time-based generator, we can observe the time period. Now, front panel controls: power on switch, intensity, focus, time base or time per division, volt per division and trigger level. These are the front panel controls. Applications of CRO: it can be used for AC, DC voltage measurement, time period measurement, frequency measurement, phase measurement, study of different types of waveforms, also in case of TV, radar and medical instruments, and for component testing as well. So this is all about CRO. Now let's move to the next instrument, that is function generator. Function generator, it provides sine, square, triangular waves with a frequency range of few hertz to certain kilohertz or megahertz. The frequency can be changed by using frequency control on the front panel control. As shown in this diagram, there are two constant current sources, upper constant current source and lower constant current source. This is the upper constant current source and this one is the lower constant current source. It can be controlled with the help of frequency control network. After this one is the integrator circuit. Here in case of integrator circuit, in feedback path capacitor is connected. At the output side, we can see voltage comparator multivibrator, resistance diode shaping circuit and amplifiers. And here the feedback is provided. So let us discuss the explanation of this block diagram of function generator. The upper current source supplies a constant current to the integrator whose output increases linearly with time. This one. The output voltage is given as VO is equal to, it is integrator, so minus 1 upon C integral of current with respect to time. The voltage comparator multivibrator changes the state at a predetermined level on the positive slope of the integrator's output voltage. This change of state cuts off the upper current supply, this one, to the integrator and switches on the lower current supply. So this one is cut off and the lower constant current source is now in working condition. The lower current supply provides a reverse current to the integrator. It is shown in this way, so that its output decreases linearly with time. When the output voltage reaches to the predetermined level on the negative slope of the output waveform, the voltage comparator changes the state again and cuts off the lower current source, this one, and switches once again upper current source. The voltage at the output of the integrator has triangular waveform whose frequency is controlled by current supplied by constant current sources. The comparator provides a square waveform with same frequency. The triangular waveform is converted into sine with the help of wave shaping circuit or network, in which diode resistance networking or diode and resistors are connected in a network form. The amplifiers are used to amplify the output signal. This function generator provides sine wave, square wave, triangular wave with frequencies hertz to certain kilo or megahertz. This is the application of function generator. One more application is it can be phase locked to a frequency standard. Its output waveform is generated with the help of frequency, with the help of accuracy and stability of standard source. So this is all about function generator. Third instrument is digital multimeter, DMM and AMM. We know the advantages of DMM. It is really very user friendly. So let us begin with the block diagram of digital multimeter. As shown in this, it consists of DC voltage attenuator, rectifier and attenuator, current to voltage converter, resistance to voltage converter, ADC, that is analog to digital controller converter, counter circuit and digital display. DC voltage measurement. For DC voltage measurement, the selector switch S connects the DC voltage under measurement to DC attenuator, ADC, decade counter and display unit. ADC converts an unknown voltage into pulses which are proportional to the input voltage. These pulses are counted and the count is obtained on the display unit. Next block is for AC voltage measurement. For AC voltage measurement, the selector switch S connects AC attenuator along with rectifier to ADC. The ADC again then it is connected to counter circuit and digital display. AC voltage is converted into DC by using rectifier and then it is given to ADC. The pulses given out by ADC are counted and the count is displayed on the display unit. The third part is for current measurement. For current measurement, the current is passed through current to voltage converter as shown in this figure. The voltage drop developed across resistor now is the input to ADC, which produces the output and it is directly proportional to the unknown current. The last one is for resistance measurement. For resistance measurement, a known current produced by constant current source is passed through a resistance under measurement. The voltage drop across resistor is applied to ADC. This produces a reading that is proportional to the unknown resistance. Advantages: numerical readout reduces human reading errors. It reduces interpolation error, eliminates parallax error, increases reading speed. It provides output in digital form. Automatic range selection and overload indication is also there and high resolution. So in this way, we have discussed from first chapter instruments, all three instruments, that is CRO, function generator and DMM in detail. Thank you.